Hi, it's me Mansa here, and I'm here to talk about the detection of radicals from the electron spin resonance. So, here, before we need to start about the electron spin resonance (ESR) to detect the radicals, you must need to know about the term radicals and the spectroscopy. After you get to know what are those terms, it is easier for you to understand the problems. So here let's start from the radicals. So radicals are basically called the free radicals, and the radicals, they are also the ions or the molecules that contain at least one on-pair electrons. So here you need to remember, here it's on pair, and also at least one or more. Um, uh, Here it is at least one or more unpaired electrons. So the most molecules contain even number of electrons. Okay, here, so example here is the hydroxy HO group, a molecule that has one unpaired electrons on oxy atoms. So so it is called the radicals here. So they are also the ions or the molecules. Okay, don't get confused. So now let's start the uh, term spectroscopy. What are spectroscopy, or what is spectroscopy? So here it is the study of absorption and emissions of light and other radiation by matter. Here it is the absorption and emission of light, or you may also call or radiation. So here you may also call the radiation. So it involves the splitting of light into its constituent wavelength. Okay, it is the term. So it is spectroscopy. So let's start the electron spin resonance, that how it detect the radicals. So here radicals can be detected spectroscopy. I already mentioned what is spectroscopy here. So radicals can be detected spectroscopy using electron spin resonance technique. It is basically a technique. Okay, ESR, its short form is ESR. As an ESR spectrum arises only from species that have one or more unpaired electron, not a paired but a unpaired electron, that is free radicals. Here the radicals, here it is unpaired electrons, so here it's of free radicals. Okay, radical. So this method can be used to detect the presence of radical and to determine its concentration. That this method just not only detect the presence of radicals, but also it helps you to determine their concentration. Okay, so the structure of the free radicals can be obtained from the splitting pattern of the ESR spectrum. So splitting pattern, it means that the splitting here, it is the splitting of lights or radiation. It means that the light or radiations. Okay, so now when the electrons are paired, they have opposite spins, which leads to cancellation of their magnetic moment. So if the electrons are paired, then what happen is there is the cancellation of magnetic field, and it the paired electrons cannot be detected by ESR. What we uh, what we learn here is the ESR technique only detect the unpaired electrons. Okay, not a paired one. So here there is a cancellation of magnetic field when the electrons are paired, and because of this the paired electrons cannot be detected by ESR. But species with unpaired electrons, it means that the free radicals have a net magnetic moment and can be detected by ESR. So you need so the main information you need to know about is the paired electrons and the unpaired electrons. Okay, you must have to keep it in mind. Only the unpaired electrons can be detected by the ESR because the unpaired electrons have the net magnetic moment. So now the CH3 radical have four signals in its spectrum. And now, so this is the idea about the uh, electron spin resonance to detect radical. And here I'm going to give you the examples. Here I set you the example. So benzene radical C6H6 has 7 peaks in ESR spectrum. Here 1 2 3 4 5 6 and 7. It has 3.7 gauss. And so gauss means here it is the unit of measurement of magnetic flux density. It is the amount of magnetic field in particular area, and 1 gauss corresponds to 10 to the power minus 4 Tesla. Tesla, it is the international unit. Okay, so here is the figure of ESR benzene radical. So this is the whole idea about the electron spin resonance to detect the radical. Thank you for watching.